joining today's webinar, Extending Spring Integration for Splunk, with Damian Dallimore and Dave Taransky. Before we begin, just a few housekeeping items. All attendee phones are muted. Your audio is being streamed through your computer and speakers. If you're having difficulty during the webinar, then you want to dial in, you can click on the Request Phone button on the attendee control panel, and the dial-in information will be provided. Or you can send a note using the Questions tab. We encourage you to ask questions during the webinar using the Questions section of the control panel. Simply type your question and press Send. The speakers will address as many questions as possible at the end of this webinar. This webinar is being recorded and will be available on our YouTube channel, SpringSource Dev, within the next 2 weeks. And now I'd like to turn the presentation over to Damian Dallimore. Damian?
Welcome along, folks, to this webinar. Today we're going to be giving you an overview of the new Spring Integration Splunk adapters. So before we get started, I'd just like to take a moment to introduce the two presenters, myself and David Taransky. My name is Damian Dallimore, and I work at Splunk as a developer evangelist. Basically, in this role, I am building Splunk apps and add-ons and various tools and frameworks for developers to use to build solutions against Splunk. And most of my work ends up on splunkbase.splunk.com or over at GitHub. When I'm not building stuff, I like to get out and about into the community. I do a lot of events and conferences where I can share my passion for developing on the Splunk platform. And prior to working at Splunk, I've got a pretty extensive background in coding and architecture, mostly in the enterprise Java space in many different vertical industries. I'd like to introduce my co-presenter now, David Taransky.
Hi, everybody. I'm excited to be here talking to you today. My name is David Taransky, and I'm a senior software engineer with the SpringSource division of VMware. I'm currently the lead on Spring Data Gemfire and also to Spring Integration. So I wrote the Spring Integration adapters we're going to.
Oh, I seem to have lost comms here for a second. David, are you there? Okay, so I've lost communications with David for a second. So I'll just give you an overview of what we're intending to talk about today. Obviously, we want to give you an overview of what Spring is and what Spring Integration is, and David will be covering those topics there. Then I will give you an overview of Splunk and the developer platform, the Splunk developer platform, and then we'll segue into the new Spring Integration Splunk adapters that we've created. And then we'll show you a bit of code and some working demos of the new Spring Integration Splunk adapters. We'll get a bit of data into Splunk and play around with that as well. And also at the end, we'll have time for some questions, so feel free to fire those our way. David's just temporarily dropped off, so what I'll actually do is I'll just jump. Oh, is David back on?
Yeah.
Oh, great. Perfect timing, David. So I'd like to hand it over to David to give you an overview of Spring and Spring Integration.
Thank you, Damian. So I'm going to give a brief overview of Spring. I assume that most of you are familiar with Spring already. We just celebrated our 10-year anniversary as an open source project. Traditionally, Java developers went to Spring as an easier alternative to Java Enterprise Edition for developing enterprise applications with Java. The three main pillars of Spring are depicted here on this diagram. The first one, DI, or dependency injection. Spring was the first widely adopted framework to be based on a dependency injection pattern, and very powerful, made things very easy and flexible and configurable, allowing allowing developers to swap different implementations of classes that would be used, say, for data access objects, etc. So it would be very easy to swap out a Hibernate data access layer with a JDBC data access layer. In addition to dependency injection, Spring was one of the first frameworks to employ AOP, or aspect-oriented programming. And the combination of DI and AOP are very powerful. AOP is used internally by Spring Framework to support declarative transactions, or where you annotate your service classes at transactional, and Spring will take care of the transaction demarcation for you, etc. AOP is also behind Spring Security and annotating methods that can be secured declaratively, and Spring MVC controllers, things like that. But also, Spring AOP exposes these mechanisms to developers so you can provide your own aspects or your own advice for cross-cutting concerns in your application development. The third leg, besides dependency injection and AOP, is really enterprise integration, or tools that allow integration through things like security, things like data access, Hibernate, JDBC, also messaging, JMS. We've had Quartz integration, caching. All these things have been part of Spring for many years. Here, this third layer is labeled TX to remind us about declarative transactions, which are definitely an enterprise application concern that you would want to have available out of the box with a framework like Spring. So this is what traditionally attracted millions of Java developers to Spring. Today, we've evolved quite a bit, and our focus is now on, first of all, having a common application framework that you can deploy transparently, either on a cloud, something like Cloud Foundry, or Amazon or Heroku, or on-premise. You don't really have to change any application code to do that. These things will deploy equally as well. We're also compatible with the major application servers, so completely interoperable with Resin, WebSphere, Glassfish, etc. So, in addition to that, a big push these days is with NoSQL data sources, which are commonly used for big data, or some offering more flexibility versus a traditional SQL-based data store. So Spring Data provides a common programming model to make it very easy to work with Redis, MongoDB, Gemfire, Neo4j, or SQL data sources without really having to drop into the proprietary APIs. We expose the features of the specific data stores, but provide you a common programming model and a familiar programming model if you're used to developing with Spring as well. So that's Spring Data. The third push is around, again, extending the features of enterprise integration to be able, for enterprise application development, to support integration with various remoting protocols such as JMS and AMQP. And in addition, we have Spring for Apache Hadoop, which makes it much easier to develop Hadoop applications. So we believe that Spring integration, along with Spring Batch and the web features that are being offered now to support single-page web applications, asynchronous web applications, as well as traditional page-oriented web applications will play into this big data space with batch and integration being a core part of what enterprise developers are going to need to do to take advantage of tools like Hadoop. So as part of that, Spring integration is a big part of the strategy. This has been around a few years, and we're currently developing the 3.0 version in the trunk of Spring integration. If you're not familiar with Spring integration, I'll give you a brief overview, but I would encourage you to go to the project website if you're interested in learning more about it. Essentially, Spring integration implements some of the ideas and design patterns that were written about by Hope and Wolf in their book Enterprise Integration Patterns, which is widely regarded as the best work on enterprise integration using a message-oriented programming model. So here you have application components that are highly decoupled in terms of interfaces. They communicate with messages, decoupled temporarily, meaning that the receiver doesn't have to be alive at the same time as the sender, so you can use asynchronous communications. And all these concepts are very important when you're talking about enterprise integration. You have a lot of systems that you have to bring together. They all speak different languages. They have different APIs. They have different data types they're using, and essentially different remoting protocols. Essentially, you want to be able to integrate these things in the easiest way possible. So Spring integration provides a platform for doing that. The core concepts here are listed as message, endpoints, and channels. So I want to talk a little bit about each one of these. Message is a common data type in Spring integration that consists of a payload, which can be any Java object, and headers, which you can think of as a map, or a map that has string keys or a set of properties. So the payload is essentially your business data, and that's application defined. And again, it could be any Java type. The payload, as it gets passed around through a message flow, actually can change. So if you send a message to over a channel to a transformer, you get, as a result of that transformation, a new payload. So in essence, things are very decoupled, and you can't depend on the payload type always being the same, but the headers give you context about the application, and they are retained across endpoints. So this is really an abstraction of common types used in messaging. For example, a JMS message has properties and a payload. SOAP messages have SOAP headers and a SOAP payload, or the SOAP envelope includes a header area and a payload area. So this is really just a Java-based abstraction of those concepts, and that can be used independent of any protocol. An endpoint is something that processes a message. It receives a payload, and that can be a transformer, which will transform that message into something else, maybe transform XML into a POJO, or map a JSON into a POJO, or just one type into another, or select some value out of a type. Routers are an important part of a messaging application. So you have a message coming in, and you want to decide where it should go next, and that decision can be based on the content of the message itself, either on the header value or the payload value that's in the payload, or any combination of those. So you do content-based routing, you can do exception-based routing, you can do payload-type routing, or recipient list routing, which basically sends a copy of the message to a list of recipient or downstream endpoints. A bridge is a trivial type of endpoint, which basically passes the message as is from one channel to another without changing it. Polar is used in asynchronous applications, and we're going to see an example of this in Damien's demo a little bit later. Essentially, you can query a source for a message or for content at a periodic interval, or triggered by a cron expression, or something like that. But basically, you're executing or looking for input at a certain frequency. Service activator is something that would be similar to a transformer. Does not have to produce a result, but would be backed by some custom POJO. So you basically say, here's the bean I want to use, and here's the method I want to invoke on the message content or the payload. That would be a service activator, or a way to do some custom integration between this messaging system and some other component. Aggregator and splitters are kind of converses of each other. An aggregator will take messages from a number of different channels and aggregate them, say, into a list or a collection, or using some custom aggregation strategy. Splitter is the opposite, taking a collection of messages and sending an individual message for each item in the collection. These are not all the endpoints, but just to give you an example of what an endpoint is when we talk about endpoints. And a channel is something that is an abstraction that's used to connect endpoints. So messages are sent or received on channels that are attached to endpoints. So when we talk about channels in Spring integration, we can have direct channels, which are basically communicate using memory, or they can be publish-subscribe or peer-to-peer messages, or you can back a message channel with a queue, which will provide asynchronous communications. So messages will be queued up until a receiver is ready to receive it. Channels are frequently backed by channel adapters. And so this is what enables remoting protocols such as JMS, AMQP, HTTP or HTTPS, FTP, Twitter, FileIO, SOAP, and the like. And now with the Spring integration Splunk adapters, we have Splunk adapters as well, which we will go over a little bit later in the presentation. Spring integration, to emphasize, is not an ESB. There's no runtime server or anything that needs to be deployed. It's just adding Java libraries, Spring jar files, and a Spring application context to your Java application. And it supports a declarative configuration of message flows using a pipes and filters type of model. And typically, there's very little Java code required to develop a Spring integration application. With that, I will turn it back to Damien to talk about Splunk.
Great. Thanks, David. That's a great overview of Spring and Spring integration. So I'm going to give you guys a bit of an overview now of what Splunk is and what the Splunk developer platform is. So what actually is Splunk? Well, Splunk is an integrated platform for collecting all of your machine data, searching over it and correlating it together, and then visualizing it as well. We live in an era of data that exists in a variety of heterogeneous formats, from completely unstructured data through to semi-structured data to reasonably well-structured data. There's a large volume of this data, and Splunk's pretty good at collecting it all and delivering valuable insights into what it can hold. The answers are in your data. So when I say heterogeneous data, you've got your traditional, machine data sources of log files and application metrics and maybe some metrics that come out of management and monitoring interfaces. But you can look beyond that and you start thinking about the Internet of Things, and you have, obviously mobile devices, thermostats in your house that are connected up to the Internet now, all the various different social media streams, publicly available data, weather data, SCADA devices, embedded devices, all sorts of proprietary systems that are emitting machine data. You can feed all of this into Splunk and correlate it together and get some really awesome visibility into what's going on. A few of the cool features of Splunk, I'll just go over those. Splunk doesn't enforce a schema on any of its data. This is one of its strengths and how it's able to deal with so many different formats and sources of data. It applies a schema on the fly. There's no need to define or enforce a schemaized structure up front. All of its field extractions are dynamic and completely late-binding. Splunk is a real-time pipeline, so you can have real-time visibility of all your events coming into Splunk. You can execute real-time searches, and you can also queue up real-time alerts, which is a very powerful feature. The Splunk platform is very open and extensible. So, what you get out of the box, you might want to, tweak it and change it and extend it to the particular scenario that suits your environment. You can write your own custom search commands. You can write your own custom data collectors. You can even extend the REST API with your own custom REST commands, or you can write your own custom visualization modules if you require it. Out of the box, Splunk's very powerful and has a lot of great features, but it's also very powerful in allowing you to extend it to your particular needs and wants. Splunk offers many different ways of getting your data into Splunk. Out of the box, you've got your standard network style transport of TCP and UDP and REST. Of course, there's file and directory monitoring, but you can also write your own custom scripted inputs and modular inputs to perform any sort of data collection logic that you may require that's not available out of the box. At splunkbase.splunk.com, lots of people contribute Splunk apps and add-ons freely, which you can download and use. And there may be something there that, you can just use out of the box, and it's going to give you great value in terms of collecting data and visualizing your data. A few architectural features. Splunk has a highly available distributed architecture that allows Splunk to scale out to hundreds of terabytes per day of data collection. And Splunk Index Store will replicate over commodity hardware. Splunk provides comprehensive controls for data security and retention and aging. You can control access and visibility of your data down to a very granular level. And it's also got fine controls for how long you want to keep your data and where you want to archive your data off to. You might want to archive data off for regulatory reasons, or you may not need all of your data on more expensive storage. You might want to archive it off to cheaper storage and just reanimate it at a time that suits you for performing Splunk searches upon it. Splunk is a platform in the data center and has lots of bidirectional integration options with other data sources. There is a freely available app on Splunk Base called Hadoop Connect, which allows bidirectional communication with Hadoop. You can pull data out of Hadoop, or you can execute Splunk searches and send data off to Hadoop. Splunk could integrate with Cassandra or Amazon S3 and Glacier and Mongo, or a relational database management system using Splunk DB Connect. And, download it and try it for free. Go to splunk.com and start playing around with it. So how can developers take advantage of some of these cool features of the Splunk platform? Well, it just so happens that every aspect of the Splunk platform is exposed via a comprehensive REST API. Out of the box, when you download Splunk, it essentially comes in two parts. There's the core Splunk engine, and then there's a very rich Splunk web UI, which has a lot of great functionality out of the box. And the Splunk web UI actually communicates to the core Splunk engine via the REST API. But you don't have to use the Splunk web API if you want to build your own custom apps on top of Splunk. Then you can program to the REST API directly. And we have numerous different language SDKs which sit on top of the REST API to make that a lot easier for you. So what are some of the typical use cases in which a developer might want to build on top of Splunk? Well, there are three main ones which we've identified. First one is utilizing Splunk throughout your dev test processes. You might want to use Splunk to centralize your logs and your metrics, speeding up development, getting insights into what's going on in your code throughout development and test so you can deliver better software through its qual and prod. You might want to integrate the insights from Splunk search results into your testing sessions to enrich the quality of your tests and hence the quality of your delivered code. And you can use Splunk as a powerful tool in your DevOps armory. You might use Splunk to integrate various different data stores within your infrastructure into a cohesive kind of single pane of glass solution. You might have existing management and monitoring tools, and you want to take some data from those, then take some data from Splunk and integrate these together into a cohesive single monitoring dashboard, and correlate several disparate systems together. Talking about Splunk as a platform in the data center, you might already have other existing tools in play, and you might have an investment in those tools, but they have valuable data that you can send out of those tools and into Splunk, and then allow your developers just to develop on top of Splunk, correlating together the data from all of these different systems in a nice integrated approach. And you might just want to build big data solutions in a completely standalone mode. Developers don't have to know how to do MapReduce. They don't have to know how to code a job or code the map or combine or reduce algorithmic steps. Actually, under the hood, Splunk uses its own implementation of the MapReduce algorithmic approach. But developers can just focus on utilizing the skills they're familiar with and getting productive and building the big data apps a lot quicker with the language of their choice. You might even want to integrate some of your Splunk search results into your core line of business applications. Splunk really lowers the barrier of entry into allowing developers to more rapidly build big data apps. So I mentioned the Splunk REST API before. It exposes an API method for every feature in the product. Whatever you can do through Splunk's web-based UI, you can actually do through the REST API as well. The typical things that you're going to be doing as a developer on top of Splunk are programmatically running Splunk searches, inputting data directly from your code into Splunk, and maybe managing Splunk. You might want to create your own custom management widgets as well. Splunk's REST API is obviously completely RESTful, and its requests are get, post, and delete HTTP methods. The responses you get back are going to be in Atom XML format or JSON. And if you're executing a Splunk search, you have many different options for the data format which you want to get the results back in. You can choose to have it returned back to you in CSV, JSON, XML, or its raw format in which it got indexed in Splunk in. And there is comprehensive versioning support as well. So the REST API exposes all these hooks into using Splunk. We want to make it as simple as possible to use that REST API. So to do that, we build SDKs on top of the REST API, and we've built these in 6 different languages at the moment. We have JavaScript, Java, which we'll be focusing more on in this talk, Python, PHP, Ruby, and C#. And as these are just a layer of abstraction on top of the underlying REST API, all Splunk functionality is accessible via these SDKs. We're just trying to make it simpler for developers to use the Splunk REST API. So I'll focus on the Splunk SDK for Java because this is actually what the Spring integration Splunk adapters are using under the hood. You can go and get a hold of this from GitHub. Out of the box, there is project-level support for Eclipse and IntelliJ IDEs, but you could use any IDE you wanted to. There's no real mandate around that. It requires JRE 6+, built with Ant, and obviously you need Splunk installed, which you can just go to splunk.com and download that, and it's got a free license. Lots of code examples over at dev.splunk.com and also in the project folder when you clone that from GitHub. And we've got some tutorial videos available as well on dev.splunk.com, which will run you through cloning the SDK from GitHub, getting set up in Eclipse, and doing some simple Hello World style stuff to get you started. So what happens when the Spring world and the Splunk world collide? Well, essentially, we're doing the same thing. We're trying to build tools and frameworks for developers to increase their productivity. So if an SDK makes it easier to use the underlying REST API, then a declarative enterprise integration framework like Spring integration makes it easier to build solutions that need to integrate, transform, filter and route your data from all your various different sources. So that's why we now have the Spring integration Splunk adapters. They're going to make it easier for developers to integrate Splunk into their solutions. And particularly Java developers who are familiar with Spring. They can build Splunk-based solutions in a declarative semantic that they're most familiar with, and that declarative semantic being the Spring framework. So with that in mind, I'll now hand it over to David Taransky, who will give you an overview of the newly developed Spring integration Splunk adapters.
Thanks, Damien. So I'm going to talk a little bit about the Splunk adapters for Spring integration. As with other Spring integration adapters, these are supported by an XML namespace. And so in this case, the namespace in Splunk needs to be added to your Spring Bean definition file. Spring integration essentially is a Spring Bean configuration file that's used to build a Spring application context. As you'll see during Damien's demo, it'll be a little more clear. First thing you want to do is connect to a Splunk server. And so you're creating a bean that holds the Splunk server connection. And so you give it an ID because you're going to need to reference it in the adapters. Typically, you'll need a username, password. These don't have to be hard-coded in the XML. They could be in a properties file and replaced here, so they don't need to be stored in the clear here. But username, password, you might have an owner. In this example, we're showing a timeout of 5 seconds, which means if I fail to connect for some reason in 5 seconds, I'll throw an exception. But in the happy path, we'll connect to a Splunk server, and that's what we'll be using to do our Splunk communications and integration. When we talk about inbound adapters in Spring integration, this means that anything that comes from that source will be sent to a channel. So we're basically binding a channel to Splunk for input. And when we talk about input with the Splunk SDK, we're performing a search, and there are several search modes supported by that SDK, blocking normal real-time export or safe search, which you would be configured using the Splunk admin console and given a name for that safe search that you can execute. Also, the SDK exposes certain time ranges, so you want to execute that search. It might be a lot of data for that particular search criteria, but you're just interested maybe for any events that happened today or the previous day. So we'll see an example of that. On the outbound side, this again is bound to a channel. Any message, Spring integration message that comes across that channel will be sent as is to Splunk. And so with Splunk, you can write to a named index. You could submit a request using the API that uses the REST request, or you can write data that's bound to a TCP port. So there's something called the TCP input that you can configure in Splunk, so a dedicated port that's just going to be listening for data. This question came up the last time we did this webinar, and so I want to mention that the TCP port is what you would use if you want to stream a high volume of data. That will connect to that socket, connect the socket to that port, and we'll leave it open as long as your application context is open. So any data that comes across will just be streamed right across to that port. The submit type writer will use a REST request, which will open an HTTP session and close the socket after each request. So easier to use. It may be more high level, maybe a little bit better exception handling than the TCP port, but it will have you'll incur the overhead of opening a new socket connection for each request. So that's the major difference, I would say, between those. The message payload for these adapters is a Splunk event, and we'll talk about that a little bit later. Right now, that's included in the Spring integration Splunk jar file, and very convenient for creating and serializing Splunk data using these APIs. Current release of Spring integration for Splunk is at a milestone release that's 1.0.0 M1. So let's take a look at an example of the inbound adapter. Now you see we have an element called Splunk inbound channel adapter in the Splunk namespace, and it's got a number of attributes. Not all of these are required, but this illustration is just to show the kind of things you can do with it. Auto startup, it means this adapter needs to be started manually or from some external source if it's set to false. By default, if you don't have an auto startup attribute, it will be running as soon as the application is started. But for whatever reason, if you're streaming data to Splunk, you may want at runtime to shut it down or to be able to start it manually from some other application. So here we have auto startup false. The Splunk server ref attribute is a reference to the Splunk connection. That's required, obviously, so that we know which server we're talking to. And we need a channel which will take this data, this inbound data coming from Splunk, and send it as a Spring integration message to that channel to be processed downstream in the message flow, however it's defined by your application. In this case, we have a saved search mode, which means we'll be executing a saved search. So if we have that mode, we need a saved search attribute, which is a little bit lower down here, which is called saved search in this case, to indicate which saved search we're actually executing here. You see also an example of the time range attribute, so we're only interested in the previous day's data, and we have a limit of 1,000 results per query. We're also backing this with a polar, which is a standard Spring integration component, and in this case, we're going to run this search every 5 seconds. So we'll be getting new data continually is what we expect. So this is the inbound adapter. This, again, is a Spring bean definition using the integration Splunk namespace and the integration namespace. So basically, behind the scenes, we're creating Spring beans that are going to do this work for you and be configured correctly to execute the search against the server that as it's configured. So that's all that's really required to get data into your application from Splunk. The outbound adapter, a little bit more complicated because we have different modes of writing. Again, I mentioned previously you can use an index writer or submit writer or TCP writer, the TCP writer being most appropriate for streaming large volumes of data. The submit writer uses the API submit request method that will, under the covers, execute a REST request. Index writer, I believe, will also use a REST request, but that's more appropriate for writing to a named index. So there are some common things that you configure with the inbound channel adapter, but there's also configuration attributes specific to each writer. So for that reason, there's a child element of the outbound adapter. We tell it what kind of writing you want to do, and that can be configured further with specific attributes for that mode of writing. So any message that comes from your application now will be output to Splunk. And in this case, we have an ID for this outbound adapter. We have a channel that we're bound to. Again, we need the reference to the Splunk server. And then there's things like source type and host regex, which means something specific to Splunk and helps with indexing the data and so forth. So it's a good example of an outbound adapter. Again, the inbound and outbound adapters all require a certain type of payload. It's expected to be a Splunk event. So that's a class that's provided in the Spring Integration Splunk library. And a Splunk event basically encapsulates name-value pairs. So you can think of it as holding a map internally. So that map gets serialized as a delimited string of pairs that Splunk will be able to parse. So very simple, but useful. In addition to that, Splunk has provided various specialized types that are commonly used with Splunk mostly in the ops world. So things that Splunk is commonly used for are, say, auth events, which are used for security monitoring, email events for monitoring email traffic events for general network traffic, Windows admin events, things like that. So if you're doing that sort of thing in your application, then we have specialized Splunk event types. These are subclass of Splunk event that will also work with these adapters. They have commonly known keys, so you don't have to look up, what is that key. These are all declared as constant fields, the keys, and also have getters and setters that are specific to that type of event. So there are, I think, over a dozen different event types that are supported here. This is just an example, so you'll be aware of it. So that's a Splunk event. So if you're going to try this, because this jar file is available as a milestone release, we published to the Spring Source milestone repository, and the URL for that name and repo is https://repo.springsource.org/milestone. So you would need to put that in your POM and then simply declare a dependency on Spring Integration Splunk, and you're off and running. Then you should be able to run these examples. If you want to take a look at the source code and see how we did this, there's a Spring Integration Extensions repository on GitHub, and you can look under that. There's various extension projects under that repository. So if you look under Spring Integration Splunk, you'll see the source code, but also the documentation. Look at the README, which has more details about how to use and configure these adapters. So with that, let's get right to the demo. I'll turn it back over to Damien. Thank you.
All right, great. Thanks, David. So here's what you've all been waiting for, probably. Time to have a look at a little bit of code. So what I'm going to show you here is a couple of simple demos that I created. One of them is going to show the Spring Integration Splunk outbound adapter for getting data into Splunk. And the other demo is going to show the Spring Integration Splunk inbound adapter for executing a Splunk search and integrating that into your Spring Integration application. So the first demo I'm going to show you is the Spring Integration Splunk outbound adapter example. And as David alluded to earlier on the presentation, as you can see, there is very little Java code required. Basically, all the hard work is done declaratively in the Spring Integration XML config file, and all I'm doing here is loading it up and starting the context. So to see what's actually going on, we need to go and have a look at the XML config file. And you've got the standard header data for pulling in the various Spring schemas, so we'll just skip over that. The first thing is we're just pulling in an include file, which has the bean in it for connecting to the Splunk server. So we can just have a look at that file here. And as you can see, we've got the information for connecting to our Splunk server, which is just a Splunk 5.0 instance I have running on a VM locally on my workstation here. So we've got the host name, the port in which to connect to the REST API. The default port in Splunk is 8089. You can change this to whatever you want, but that's just the default port. and the credentials for authenticating against the REST API. So in this example here, I need a source of data. So Spring Integration Framework comes with some Twitter adapters. So I've decided to use a Twitter inbound adapter for polling various tweets and using this as my source of data. So what I've done here is I've just set up my publish subscribe channel to Twitter. And in the Twitter inbound adapter, I'm specifying a Twitter query to go and pull down some tweets. So I'm looking for any tweets that have the hashtag Splunk or Spring, or just to make sure I actually get some data, the hashtag music. I'm pretty sure there's somebody somewhere in the world who's going to be tweeting with a hashtag music in it, so I'm pretty assured of getting some data there. And I've got my poller here, so every 5 seconds, just go off and poll Twitter, looking for that pattern, and only return me a maximum of 100 messages. I don't want to swamp my entire system. So I'm going off to Twitter, pulling these messages in, then I've wired up a service activator, and all this service activator is doing is dumping the raw messages out into the console so you can see what's actually coming back from Twitter in its raw format. Now we start to get to the interesting part of the config file, and this is where we are converting the tweet POJO object. As David mentioned before, Spring Integration is message-based. It's passing all these POJOs around, which are our messages. So we're taking the tweet POJO object, and we want to convert that into a Splunk event POJO object. So this is what I'm doing here with my transformer. And this bean here has all the logic for converting from a tweet POJO into a Splunk event POJO. Then once I've got my Splunk event POJO, I can now pass that to a Splunk outbound adapter. And this outbound adapter is going to use the Splunk REST API to submit events directly into Splunk. As I've mentioned before, there are essentially 3 ways of sending your data into Splunk. There are 2 REST methods, and there is a raw TCP streaming method as well. But just for simplicity's sake, I'm just using a simple HTTP REST submission method here. So it's going to take that Splunk event object, and it's going to go and put that into the Spring index in Splunk, which is just a data store area where I want this data to live. And I'm tagging the event with a little bit of Splunk metadata. I can use these tags later to make it easier to search and retrieve the various events that I'm interested in. One of the benefits of the Splunk event object is it's going to encapsulate the logic required to output the event in a best practice semantic format for Splunk. By best practice semantic format, I mean the data is the event being submitted to Splunk is going to have a consistent timestamp, and all the fields are going to be in a consistent key equals value pair format. Now, the benefit of that is that when the data gets into Splunk, there are no more field extractions that I have to perform. Splunk can automatically figure out that it's in key value pair format and extract the fields for me. We could also submit it in JSON if you want. Splunk can natively eat JSON format if you wanted to log in JSON. So that's enough code. Let's actually run this outbound demo now and see if we can pull in a little bit of data from Twitter and send it up to Splunk. So run the demo over here. The demo is starting up. And what do you know? It's gone off and it's actually found quite a lot of tweets already. So these are the raw tweets that are coming in on the Twitter inbound adapter right here. And the service activator step here is just doing system without the print line. That's why you're seeing this data out in the console here. The tweet POJO is being transformed into a Splunk event POJO, and these messages are being written up into Splunk. So now would be a good time to actually go over and have a look at these messages arriving into Splunk. So here is my Splunk instance running locally on a VM on my workstation. I'm just going to pull up the default search app. And here are some search commands that I wrote before and just saved. So I wouldn't have to type them live, where I'd usually probably make a typo. So I've gone and looked in the Spring index for all the source types called Twitter feed. And as you'll see over here, I've told Spring that I want my events to be written into the Spring index with a source type of Twitter feed. So I've used that metadata to narrow down my search. But this search is pretty useless. It's looking over all time, so this is going to have all the data that I've used in the preceding days when I've been playing around with these demos. I'm actually kind of more interested in maybe what's happening in real time. So I'm going to set up a real-time window of 5 minutes. So this is a sliding 5-minute window in which I can see real-time events coming in. And you can see here in the timeline view, it's already found a bunch of events, scanning over these, and there you go. There's 65 events that have come into Splunk in the last 5 minutes. Now it's jumped up to 74, 77, and as you can see, this real-time search is just going to keep on sliding this 5-minute window across the data as it comes in. Down here in the search, you can just see the raw data that's come in. The data, as I said, has come in a best practice semantic format. So you can see it's got a standard timestamp that Splunk has automatically detected and used that as the index time of the event. And all the fields in the messages are formatted in nice key equals value pairs. So the cool thing about this is then I can just extend this simple search and go and tabularize some of the data. And maybe Splunk has automatically extracted the from user from all of these events, just like that. And that was very simple. Or we might want to do something, slightly more complex and add another column in there, the from user and the actual text of the tweet. Now that's cool. If things are coming in a nice best practice semantic format, you might pump it in a JSON, a key equals value pairs, and Splunk can automatically extract your fields for you, and you can then use those fields to create various visualizations. But what if I've gone and figured out that there's some other fields that I'm interested in? And I can already kind of see that. I can see that we've got some retweeter information. What if I want to go and pull out that retweeter information into a field of its own? Well, again, it's very easy to do dynamically at search time with Splunk. We don't need to have a schema up front. So I can write a slightly more complicated Splunk search command, which goes through and dynamically extracts the retweeter out into a field called RT_user. And we can see that down here right now. Likewise, some other interesting information we might see is there's a hashtags. That's great. I want to go and pull out all the hashtags so I can write some Splunk search commands which maybe analyze, what are the top hashtags people are, tweeting about at the moment. So we can go over here and use a tweet top hashtags. I've gone through and dynamically extracted all the hashtags based on a regex pattern into a field called hashtag. And then I've gone through and piped that into another Splunk search command to tell me what are all the top hashtags that people are currently tweeting about. Again, this is an all-time search, so maybe we'll want to go and turn this into a real-time search and see what we've got going on there. We should see some events starting to come through. There we go, 179 events, 183 scanned events. So that's cool, I like tables. Tables are nice. We've taken the raw event data that's come in. We've made it slightly more human readable in the table format. But what if I want to visualize this more graphically? I want to create a dashboard and share that with other members of my team. Well, again, it's very simple. I don't have to be a rocket scientist to do this. I can just go and save the search. I'll just call it foo for brevity's sake. And I'm going to put it onto a panel called foo as well, a dashboard panel called foo as well. How do I want to visualize this? I think a pie chart might work pretty well with this data down here. And we'll finish that, and that's done. Now I can go up to my dashboards menu, and voila, there's a dashboard I just created. And there we go. Very simple. I've dynamically extracted all of the hashtags from those tweets. And I've created a real-time dashboard. This pie chart should be updating in real time. Now, I may want to go and maybe augment this and add some more visualizations to the same dashboard. So I can go back here, and a search I might be interested in is what users are tweeting the most at the moment. So let's go and do a count of the tweets by user. I haven't had to do any other field extractions here because the from user field was already well formatted as a key value pair in my input data. I can go and maybe save this. I'll call this one foo2. well, I don't want to create a new dashboard because I just created a dashboard, so I want to add it to that existing dashboard I just created. So I'll do that. And I'm kind of having some good mojo with pie charts, so I think I'll stick with those for the time being. And we'll save that. And now when we go and pull up that view over here, voila, you can see which users are currently tweeting the most and what hashtags are being included in tweets. This is a 5-minute real-time window. This is a static search down the bottom here. You can really mix it up as you see fit for your particular requirements. So that's a nice kind of end-to-end example of the Spring Integration Splunk outbound adapters. I pulled some data in from Twitter. You can see it. Actually, the Spring Integration example is still going on down here. It's still polling for tweets and pushing these up into Splunk. But the other half of the equation is the Spring Integration Splunk inbound adapter. And this is the adapter that you'd use to create Splunk searches from your Spring Integration Spring Integration app, and maybe integrate those Splunk search results into your application, or maybe pull those Splunk search results in and export them off to other systems, or whatever you need to do for your integration solution. So again, the inbound demo, just like the outbound demo, there's next to no Java code. All of the hard work is done declaratively in the Spring XML file. So if we go and have a look at the Spring XML file, it's a lot simpler than the outbound one, because all we're doing here is polling searches against Splunk and outputting them to the console. So again, the standard boilerplate header stuff, we're pulling in the various Spring schemas. We're specifying our connection to the Splunk server, again, just using an include file. Setting up our channel to pull the data in from Splunk. And then here is the Splunk, Spring Integration Splunk inbound adapter. There are many different ways of searching against Splunk. You can perform blocking searches or non-blocking asynchronous searches or real-time searches. In this particular example here, we're just doing a simple blocking search, which means the code blocks until the search actually returns its results. And the search command I want to execute is specified in the search attribute here. So this is just a very simple search command. This is going and looking in the Spring Index for all events that are tagged with the source type of Twitter feed. It's worth mentioning the time bounds that we have set up here. So the first time this runs, the search is going to look over a window of the last day, so up to a day before all the way up till now. The subsequent times that this search runs, the earliest time will then become the last time the search ran. So you're not going to get overlapping search results. It keeps the cursor of where it left off and just pulls in the latest search results. We've wired up a poller as well, so we have this running every 5 seconds. So it's performing a search against Splunk every 5 seconds. This is just quite a trivial example. I'm pulling the search results in and then just dumping them out to a console so you can see it graphically what's going on here. But to tell you the truth, in reality, for a more comprehensive Spring integration solution, you wouldn't be dumping out to a console. You'd be wiring up any one of the other various Spring integration adapters, the FTP or email or file adapters, or maybe the Gemfire adapter, or the AMQP or JMS adapters, or perhaps the JDBC adapter, or Mongo or Redis. Whatever is required for you to integrate, create your integrated solution building with Spring integration. So I'll execute this example here. I'll keep the outbound example going in the background because that's pulling data in from Twitter and sending it up to Splunk. And I'm going to search over that same data as well and pull that back into my Spring integration app. So I want to keep it running because I want some data there for me to search upon. So I'll go and execute this example here right now. And this is the inbound demo. And it's going off to Splunk, executing a search, and there you go. So this is actually pulling in all of the raw events. You can see there's quite a lot of fields. This is quite a good insight into Splunk under the hood because you can see a lot of the internal metadata fields that actually get associated with the raw events when data gets indexed in Splunk. So you might not actually want all of that stuff. You might just want to pull in, a particular set of fields. So I can go and just change. I'll stop the example first. Then I can just go and change the Splunk search command that I'm using to maybe just pull in a count of the tweets by user. And there we go. Let's try that one there. Save that. And let's execute that again. And there we go. We get a much more refined set of results now. I've just executed that Splunk search, it's pulled it back in, and that's just a count of the number of tweets on a per user basis. And you can do a similar thing for whatever particular fields or results that you're interested in. The Splunk search language, I've just been showing you some very trivial examples here, but the Splunk search language is actually incredibly verbose. If you go to docs.splunk.com, you can see the full Splunk search command reference for all the various statistical functions it offers and predictive analytics options that it offers. And also one of the great things about the Splunk search language is it's completely user extensible. If there is something that's not available out of the box, you can actually create your own custom Splunk search commands, which is a very, very powerful feature of the Splunk platform. So with that in mind, that actually ends the demos that I want to show you. I hope that gave you a pretty decent overview of, at a simple level anyway, of how the Splunk outbound and inbound adapters work, and maybe get your mind thinking about the various ways that you can take Splunk data and integrate it with many other different data sources that you have throughout your enterprise. So at this time, that basically concludes the presentation. I'm going to open up the floor now for questions. So if anybody has any questions for myself or David, please, now's the time to ask them. We have...
I got a couple queued up for you, Damien.
All right, great. We've got a lot of reference information also available at the Spring Integration and Splunk site, so I'll leave that slide up. And with that being said, let's get into the questions.
First one is from Vandit Garg. And just in case it's unclear, folks, just use the Q&A control panel to submit your question. First question from Vandit Garg. Curious about syncing between a database and Splunk. Any out-of-the-box support for that in the DB Connect app?
Yes, this is different from Spring Integration and the JDBC adapter that's available on Spring Integration. But over at splunkbase.splunk.com, you can go there and download various apps and add-ons for various integrations and custom data inputs and things like that. And we've got a free app available called Splunk DB Connect, which is used for integrating relational database information with Splunk. So there is out-of-the-box functionality for that. So I would suggest going to splunkbase.com and downloading the app and giving it a whirl for yourself.
Okay. Next question from Frank and asks, could we use a Splunk connector with an aspect definition for a Spring MVC app? The purpose is to use Splunk to monitor the main events from the application.
I think I don't know if I can answer that right here explicitly, but I'd be happy to take it offline if you want to send me an email so we can see what your use case is.
Yeah, essentially, you can programmatically send data from your code directly into Splunk. Depends how you intend to implement your aspect definition to send that data into Splunk. We've got Splunk Java logging frameworks. If you're using Log4j or Logback, if you wanted to weave that in, or if you wanted to write it to a log file and have that monitored and send into Splunk, or you want to expose the metrics via MBeans. We've got a Splunk for JMX app for monitoring JVMs and all the various MBean attributes and operations they expose. So it's really I would say yes, and it's going to really boil down to how you choose to implement your aspects.
And if Frank, if you're still on the line, feel free to post your email as a response to the question, and maybe we can follow up with you. Next question was from Helen Han. Is the host attribute in the outbound adapter where the Splunk server is?
Yeah, so the host attribute in the outbound adapter is typically going to be the host that is the source of the event. If you omit this, then it will it's gonna default to something that you might not want. So that just gives you the option to explicitly specify the host information that gets tagged with the event that gets indexed in Splunk.
Excellent. Okay. Let's see. Next question. I might not say his name correctly. Jathan, how could I use a different thread to post data to Splunk? Would this be a capability in the Splunk outbound adapter or in an enterprise integration pattern in Spring Integration?
Yeah, you could do that in Spring Integration. You can essentially, if you use a queue channel to back that outbound adapter, then that will run in a different thread. There's also the ability to attach that queue to a task executor and things like that, so you can control the thread pool at a very fine grain. So, Spring Integration provides all of that. So essentially, just by declaring a queue channel as your channel, that will run in a different thread.
Excellent. Thanks, David. Next question would be from Janos. What is the expected GA release date?
Currently, we have no hard plan for a GA release. We're not anticipating any new features, but we are looking for feedback from the community before we go to the GA release. So we're kind of feeling out developers for a period of time, and to make sure that this is working the way that people want it to work. And everything that we've showed today is fully functional and available. So we don't, without any further input from the community, expect that the GA would have many more features than what's here today.
I'll just add one thing. The underlying Splunk SDK for Java is GA'd already, but as far as the Spring Integration, Splunk extensions, they're pretty hot off the press, to tell you the truth. So we want to get some community feedback before we explicitly put a line in the sand with respect to the GA release date.
And just one further comment, I think what you guys demoed here today and showed here today obviously is available in that milestone release. Not those features are there. It works fine. It's not just demoware. This is something that people can use. It's just we'd like to get a little more feedback, right?
Yeah, like everything I showed in my demos was custom built based off the latest 1.0 milestone 1 release. So it is obviously functional.
Fantastic. Thanks for that. Next question is from Amer Mullah. Does Splunk have similar functionality to Apache Camel or JBoss Fuse?
Sorry, can you repeat the last part of that again?
Certainly, yeah. Does Splunk have similar functionality to Apache Camel or JBoss Fuse?
Well, you mean Spring Integration, Splunk adapters? I mean, it's Splunk.
No, he said Splunk in general. He said Splunk specifically, not just the adapters. I think he was just referring to that.
Splunk is a platform for collecting all of your heterogeneous sources of machine data and searching over it and correlating it together and visualizing it. So it's, you could send...
Sorry, guys. Hang on 1 second. I'm sorry. He just clarified in the chat window and said, yes, as a replacement for Spring Integration with well, something about maybe not with an application server, but he's using a lot of acronyms. Sorry, I just wanted to give you that.
So let me take a try this. As far as I know, there are no Camel adapters or Fuse adapters that written for Splunk. That doesn't prevent somebody from doing it, but as far as I know, Spring Integration is the only type of product in that space that's supported out of the box today. Not
yeah, I mean,
do it, but
we
have
a JMS connector, which could you possibly use that with Camel? I'm not too sure. I'm not so familiar with Camel myself.
All right. Thanks, guys. Okay. Just one or two more questions, and then I think we're at the end of the queue here. Let's see. Ankush Garg asks, can the inbound connector be used to extract a dashboard out of Splunk rather than just a single search?
Well, what underlies dashboards are Splunk searches. So what you're doing when you're executing a Splunk search using an inbound adapter is pulling out the same data that would be used to be rendered graphically in a dashboard. So yes, you're pulling out the same data that underpins, your pie chart or your line chart, your bar chart or your combo chart or whatever. But you just, you're obviously not pulling out the graphical rendering. You're just you're executing the same Splunk search and you're pulling out that data, and then you can go and do whatever you want to do with that data inside Spring Integration.
Excellent. All right. Last question, it seems, in the queue from Amit Patel. Do you have to be an admin user to use the REST API? If not, will the user be restricted to only their saved searches?
Yeah, so the Splunk REST API and all the objects that you're interacting with are namespaced. So it really depends. So if you want to integrate with saved searches, and you log in as the Job Logs user, then those saved searches are going to have to be visible to the Job Logs user in Splunk. Obviously, Job Logs will be able to see all of Job Logs' saved searches. These are just objects in Splunk. But if some other user or an admin has created saved searches, they're going to have to make sure that those searches have been shared appropriately. So that Job Logs has visibility into using those. This just comes down to Splunk's role-based permission access controls over the various knowledge objects. There is some good literature at dev.splunk.com on how the Splunk SDK for Java works with namespaces and how different knowledge objects are stored in a user context or an app context or a system-wide context.
Great. All right. Thank you so much. The last question was just about access to the source code of what was demoed today, and I assume, Damien, that the link that you have up on GitHub does refer to that, perhaps, or?
My current demos are just local on my workstation. I haven't published these to GitHub. I can certainly publish all demos I showed today to GitHub, and I'll get around to doing that in the next 24 hours.
Fabulous. Okay. I assume it would be easy to find, relatively easy to find for someone if they went to github.com/Splunk and kind of browse around from there.
Yeah, I'll put them in my personal repository. So you can just search for my name in GitHub, and you'll be able to find it there.
Excellent. Okay, fabulous. All right. Well, I think that's bringing us to the end of the program, guys. You want to take it home, and then I'll do make a couple little announcements after you wrap it up. Is there anything else you want to say?
Yeah, well, that's pretty much at the end of it. We've only got one more slide, and that's thanks a lot for attending. To all the folks out there, thanks to David, the co-presenter, for giving some really great insights into Spring and Spring Integration. What more can I say other than go and download the projects from GitHub and start playing around with a bit of code. Go and download Splunk from Splunk.com. There's a free version of it, and that's all you need to do to get going and then developing some solutions using Spring Integration and Splunk. So once again, thank you very much for coming along.
Excellent. And just so everyone realizes, there'll be a replay of this webinar posted to our YouTube channel, which is available at youtube.com/SpringSourceDev. Again, youtube.com/SpringSourceDev. That'll probably be out within a week or two a week or two from today. If you want to get a notification that the webinar replay has been published, probably the easiest thing to do is sign up to subscribe to the YouTube channel, or take a look on our RSS feed on springsource.org for an announcement posting that the replay's been made available. Great. Looking forward to seeing you coming back to a webinar real soon. We're going to have some interesting, going to continue with the big data theme and be talking about pivotal Hadoop distribution and Spring for Apache Hadoop next month towards the end of April. So keep an eye out for webinar announcements for late April on those topics. And thanks everyone for coming. Hope to see you again soon.